All right, let's get started learning how to ingest a scene, modify some of it with some rigid body and fracturing fun, and then write it back out as an effects sublayer, meaning kind of our collection of overrides and new additions to lay on top of the incoming scene. So you'll see what I mean. First things first, let's do 100 frames. You know, we're not going to go too crazy with our rigid body simulation stuff. This is more about understanding USD and its transforms and how that relates to rigid bodies. So I'm going to save it in my downloads area here, where my other Solaris stuff is. I'm going to call it rigid frac exercise, like so. What else do we want to do? Let's pop over to the stage where we're actually going to do our various Solaris USD stuff, and change the default viewport renderer from Karma to GL. We're not going to use Karma too much in this lesson. We'll make sure that everything we do works with Karma, but for now, we'll stick with OpenGL. And the last thing I want to do is say new pane tab type, or rather, let's split it top and bottom, and then say USD scene graph tree. This is going to be the nuts and bolts, I think, of this demo is understanding USD and how the tree works. Again, rigid bodies are meshes that have transforms that move them around the scene. They have visibility. You know, you might have the regular object before it breaks, the visibility turns off, etc. So there's going to be a lot of interaction with the USD tree itself. And the first thing we want to do for the USD tree is to start growing it. Let's use a sublayer. If we look at it, we got a backslash now. This is the root of pretty much any USD tree, or, you know, stage, if you will. Right now, there's nothing in it, but that's the root. So let's sublayer in our main, or not a library scene, rather our market scene. So click on this, ignore that it's already there. So I saved my file, again, amongst all of the demo market scene stuff. So wherever your market scene USD happens to be, go find it. In this case, it's in the library, layout, full scene.usd. So it's sublayered into the root, all this stuff. You know, and there's lots of stuff in here. We don't need to concern ourselves with all of it. All we're going to do is we're going to isolate part of this scene, modify it, and then make that into our own USD file that downstream departments can use. So we're only going to modify this jar right here. It's going to fall off the shelf onto the ground and break. So what we're going to need to do is we're going to have a rigid body simulation drive the existing geometry, and we're going to need to create new fracture geometry that we switch visibilities between, and write all that stuff out as our own USD file that, again, downstream departments can load with this by sublayering that file in too. And again, think of it as a bunch of overrides, like override the position of this, create these new geometries, also override the visibility of this from time to time, etc., and so on. Cool. Now we have all this stuff that we brought in. Let's make something of our own. Let's make a camera. While it's selected, all we see is the camera. We lost all of this. We want to add the camera to this tree. So in the merge in LOPS area, aka Solaris, we'll do just that. It will add it to our tree. So again, here it is, the camera, and here it is before we merged it in. So I'm going to minimize that. If we want to go into our camera, we can go here. It's just down here right now. If our lock is on, then, you know, just like the camera's in regular geometry area in Houdini, we can move the camera around with the lock on and it will update the transform on here. So this should be enough. You know, to reiterate, I'm going to have this jar fall off on frame 6, which I think maybe is when this magical effect makes it fall, or, you know, we'll jostle it so that it falls. Whatever the frame ends up being, we can always time shift it later. But so I just want to frame where the jar is and where it's going to fall to. Cool. So with that done, turn the lock off here. I'm going to save my file. And let's actually get that jar so that we can use it. Because currently, that jar is part of a a whole bunch of instances. You might have seen that in some other demos regarding the market scene, but suffice to say, there's a bunch of instances here. You can see the same jar being used over and over again. But as long as they aren't in instance mode, we can't actually manipulate it ourselves. So we need to put an extract instances. And we need to actually grab it. So you can use the little grabber tool here, select a primitive in the scene view. I would make sure that you're in component mode first. So geometry and component mode. And then once we do that, we can click this and try to select it. If you select things behind it, you control, drag a box around them. We just want to isolate that. Once you have it, press enter. And it should look something like this. This is the path in our tree that we were targeting. Shot back shelves contents, which is where all the stuff lived. And in any case, it said 131. So 131 was the particular instance of that jar. And now I'm going to say, let's put it somewhere. Let's put it in a new area of our tree. I'll call it rigids. So if I look at it, we should have a rigids area now. And of course we do. So what do we have in there? We have instance 131, which consists of a mesh cork and a mesh small jar with handle. Why is this jar called small jar with handle when there is no handle? These are the questions. Only side effects knows for sure. But in any case, there it is. It right now is going to try to extract it on every frame. If it was animated, that might be useful or might not be useful. I'm going to say don't have it do that. Let's just extract it on the one frame. Again, not animated anyway, but just to be sure. Now let's actually isolate this so that's the only thing we see. I'm going to put a prune in here. The prune will change visibility on things. In our case, we want to do one of these prune unselected kind of deals. Well, I'll keep that off for now. You can try to select it in the viewport. It may or may not work. Looks like we might have actually gotten it there. So again, I'm control clicking everything else, press enter. So that seemed to work. If I make it wider, we can see it in there. It's not quite what I wanted. It seems to be working though. What I want to do is make it a little bit more specific. Again, here it is, cork and small jar with handle. If you select both of these by control clicking, you can actually drag that to here. And you can see now it's more explicit. Small jar with handle and cork. I want it to be more explicit because other nodes later on are going to need to point to these meshes exactly and not to the transform itself. So either way, our result is the same here, and it's just going to help us a little bit further down the line, as you might see coming up. So again, it's prune unselected to isolate it. Sweet. Let's see what else we can do. Now, before we pruned it, we can see this jar was resting pretty well on the edge of this. I want to move it a little bit off of that shelf. So in fact, I'm just going to turn this prune off for a moment. And I'm going to say, copy parameter on this primitive pattern and say, paste it here. Because I only want to transform. I want to move this thing now a little bit. I want to have it just kind of be resting off of it a little bit. That's a decent amount to be resting off of it. So that it could conceivably still be actually resting on that, but just the slightest jostle will have it fall over. That's what I'm hoping. So something like that. And I'll say right after that, a null for rigid unfractured. Cool. Let's do another prune. We need the collider itself. I'm going to say, let's select this shelf thing here. Oop, we lost it. There you go. And again, prune unselected, just so we can see it. Cool. Like so. So we're all pretty much set up now. We've got our jar, and we've got the thing that it's going to be resting on. So what do we need to do? We need to actually modify the position of this, meaning animate it, meaning simulate it. So to do that, let's do a SOP modify. So what it's going to be modified? Well, once again, it's this. It's these two meshes here, this path of these two meshes. So I'm going to go paste relative references to here again. And if we jump down here, now we're back in our SOPs land, in geometry. If I middle click and hold, I can see two packed USDs. So these are USD primitives. USD primitives are a way of, not getting too into SOPs, but still kind of keep it USDE. That anything we do to them in here, like change their transforms, for example, that will translate back up. The SOP modify will just say, okay, I recognize these USD primitives. I see their transforms have changed. I'll just update the transforms back up here. So let's just do that. I'm going to blow through pretty quickly a pretty basic rigid body setup. So first things first, unpack USD. I'm going to do it over here in a separate path because I want, I'm going to want these USDs to be the output here later on. We'll just update the position of these based on a sim we're about to put together. But first, unpack it to regular polygons. You can see by default, it now says polygons. That's all unpack to polygons does. Oops. There you go. We want to make RBD constraints from rules. So constraints from rules. What I want is I want the cork to stay stuck onto this jar. So just by default, really by not changing anything, you can see here that we have a constraint that goes from the cork to the jar. And there you go. Very good. Easy. Again, not going to talk too much about this. Check out Applied Houdini Rigids 1 for free if you want to know more about this kind of stuff. So constraints, properties, which we can say shift click here to get all three outputs. Uh-oh, I lost it. And just click this first one, and there you go. They're all hooked up. This is just more, if you needed to mess around with the strength, keeping the strength at 10,000 will be fine for this. We want to do an RBD configure, like so. 1, 2, 3. So now we've got two packed fragments and any other general rigid body settings we might have wanted to do. And then the rigid body bullet solver itself. 1, 2, 3. Like so. And before I even press play, I'm going to say go to the ground tab, do a ground plane. I'm also going to put 20 substeps on because let's live large, It's one jar. Whatever, we can afford it, I'm sure. So there you go. What else do we want to do? Let's have it start on frame 6. Like I said, just to prove that we can. So we don't see it before frame 6. So we're going to need a time shift afterwards. And say, you know what? Maybe we should have a null out here, one of these control panel types. Because we're going to need to have a bunch of things probably be driven off of that, meaning the first frame. So go to Edit Parameter Interface, drag an integer over here, and say Start Frame. This frame. And we're also going to need to switch visibility from the unfractured, or rather, yes, from the unfractured to the fractured later on. So we'll say F frame for fractured frame. Now I don't know what frame that is yet. But I do know, at least for now, the start frame is going to be frame 6. So I'm going to copy that parameter. I'm going to jump back in here. I'm going to make that go here. And I'm going to make this clamp, or rather this time shift clamp to the first frame, which again is that. That way, let's say if I were to put this here, I won't see. It won't, any frame before 6, it's just going to keep looking at frame 6. So it'll look like it's always there, even when the actual output of this is not. Like so. Now, we don't actually want the output of this, though. I don't actually want the packed fragments per se. I want to update the position of the packed USDs. So do a transform pieces, like so. Oops. Where the first input is the packed USDs and the second input is actually this, the simulation points. And now I'll actually put this time shift in there. So it is literally just some points, but it will update this first input to that. So now it's the actual packed USDs that are doing it. And if we go back out here, you can see, voila, bonk. It's got all the materials on it and everything. So cool. That's pretty much it for this. Now I know, looking ahead, that we're going to need these simulation points in our next little phase here. So I'm just going to, right now, I'm just going to make a little null that we can point to for our fractured pieces are going to need to move with the unfractured ones, you know, before they hit the ground. So I already know that I'm going to need that. So very good. Let's see. What frame does it hit the ground? Well, it hits the ground at like 16 for now. So that's interesting, but we actually never brought in our collider, our shelf. So do a lop import over here. We can delete this now. I'm going to copy this, paste it here. And right now, let me turn this off. We don't really see anything because we're not actually asking for any specific primitives. Which primitives do we want? Well, we can get these ones. So copy that parameter. Come back in here, paste relative references, so there you go. We don't need to do much. I'm just gonna grab this RBD configure here, delete that, pass that into here. Now this doesn't move, so this should not be active, but it is a collider, so put that here. And now we should see it falls off the shelf instead. If you need some convincing, we can template it, and there you go. Falls off the ground, or falls off the thing. So I'd say about around 21 is like the last time before it really hits the ground. So 21 is going to be our so-called fracture frame. As you know, we can change all this around later on, but that's pretty good. So now we need to do the actual fracture itself. So we're not going to just modify, let's say, a position. We're going to actually create some new geometry. So for that, we'll need SOP create. There it is. What do we need to export into here? Well, we're going to want, again, I'm going to say copy this rigid unfractured node, and that prune here, we're going to want to do the copy parameter. So it'll come up. There it is. Copy parameter. These are the two meshes, again, that we need to deal with. So do a lop import. I'm going to do a control V on the actual path. And I'm going to do a paste relative references on the primitives themselves. And there you go. Now, once again, we have this import frame business. We don't need that, so delete that channel. You may have this disappear on you. If it does, it's you can control X your node away and control V to just bring it back, and then it should come back. It's something I've seen happen a few times, even though it didn't happen this time. So here's a split. We don't want to fracture the cork, we just want to fracture the bottom. So go to the split here, and for the selection, you may not have this come up by default. You can press 9 to bring up the selection mode, and make sure you go to attributes path, and make sure actually that you're in primitives mode to make sure you're even can see path. Point is, we want that. So click it, select it, press enter. One way or another, we want to isolate just the jar on the bottom, because again, we don't want the cork to fracture. There's no point. So we need to do an unpack to polygons again, unpack USD to polygons. And we want to do, this is an interesting thing. USD is mostly dealing with the path attribute, the path primitive attribute. So you can see it's literally, again, that tree path. But all the rigid body stuff deals with the name attribute. So what we have to do is do an attribute swap while we're in here. So go to class primitive, source, path, and say destination name, and it'll switch the two around. So pretty easy to do. Let's do a subdivide. I'll explain that when you're older. or more specifically, after we do the fracture, why we're doing that. And then we want to do an RBD paint to say, hey, let's just fracture, maybe, let's put more fracture-y stuff on the bottom. So you can click on the node, or rather this button here, to go into our paintbrush mode, hold shift and left drag to make it smaller. And you can see, I'm just gonna paint around the bottom here. This is, again, nothing that is so exact that you need to worry about not doing exactly what I'm doing. I just know that this is gonna hit, it's gonna fall on the ground, right? So, I just wanted to concentrate stuff down there. Because now when I do an RBT material fracture, give that a second to show up. There's a lot of nodes in there. Before I even hook it up here, I'm gonna go to the second tab, disable, or just delete it. I don't want 2 levels of fracturing. Again, we talk about this in other places like Richards 1, Applied Houdini. We're not really gonna focus on this that much today. But all you need to do is turn off that second layer, because I just don't want that many pieces is all. Change cell points to attribute, the density attribute we just made, like so. So now, when we do this fracture, we can see some fractured business going on in there. If you want to see it better, do an RBD exploded view. And again, 1 shift click, 2 shift, 3 shift click. There it is. It's all very good. We can say maybe scatter twice as many points in there. So we get more fracturing coming on here. Let's also go to the detail. Let's turn on edge detail so that we actually get some nicer looking pieces. We'll need, let's see, detail size. We'll make the detail size smaller. The smaller the detail size, the more detail we actually get. And I'll just do some values here. I don't want to spend too much time on this. But that really should be it. So now we just have some, you know, gnarlier edges here. There you go. So that's a beautiful piece of work right there. Now we do want this one to break pretty easily. So I'm going to go over to the constraints that are automatically made and say the primary strength to just be 1. Because I want this to break, I want it to hold together in air, which really any amount of strength will do, but once it encounters anything, it should break. Also under detail, turn on crease weights. This is actually why we did the subdivide now. An attribute will be made called crease. There it is. And it puts it along the new fractures. And we wanted to subdivide it so that we had these lines, these edges that come out from the crease, kind of just think of it as these kind of white areas. I want those to be as small as possible. When this is rendered using subdivision rendering, the crease will say this should be a very sharp edge. The problem is that sharpness will be interpolated down away from it also. So by subdividing, we'll just have less of that. It should probably look mostly okay, but just so you know, that's why we're doing that. And that's about it. Again, we don't want to spend too much time on this because I feel like I'm already running out of time as it is. So just connect our beautiful thing here. We don't really need to have the shelf collider anymore. It shouldn't really matter. Just turn on our ground here. Again, substeps 20 because we're living large. Let's see what that gets us. If we just press play, it's something. It behaves a little weird. And that's probably because if you go to visualize, show geometry representation, well, unfortunately there's a bug right now and you can't really see. But if you double click and go in, you can see. The actual colliding geometry is not very good. So we need to come out, go back to bullet object here, make the collision padding much smaller. So now when we go in here, we can see it's much closer to the surface. So that's good, like so, bam. Let's have it not just fall though from the start. We want it to fall from where it actually is. We want to basically become active. We want to follow the path from the original unfractured simulation. So I'm going to come to our SOP modify, go to that. I thought we made a note. Oh, it's in here. So go to sim points so that I get those simulation points that we wanted. And I can do an RBD pack before we get to the sim here. So let's take a look at that. The RBD pack can say transform those pieces based on that old sim. So now you can see the pieces are all falling that way. And actually, while we're thinking about it, we never actually got this cork back in the picture again. So I'm just going to take a configure, RBD configure. Let's put one, well, we'll need two of these, I guess. Let's put one here for the cork. And you'll actually notice, if you middle click and hold, it's still a packed USD. It did not turn it into a packed fragment because it already identified it as such. And let's also put one here after our material fracture. We never actually turned it into the packed fragments. So we'll keep these kind of in parallel. And now we can pack these both up. Uh-oh, that didn't work. So 1, 2, 3. And we'll merge these together. The RBD packs, as you may or may not recall, basically just take the low-res geometry, the high-res geometry, and the constraints that love them, and turn them into kind of like a little asset. So here they are together. And now we can just move them all at once with this. And then once we got them into the new position, we can just simply do an RBD unpack. And it'll turn them back into the constituent things here. So now that we've got them moving in the way we want them to be animated, we want an RBD configure to animate when they are in animated mode. So that's what this active and animated is. So we turn on animated, and we basically just need to change when it's active. Now we decided earlier that it was after frame 21. So I'm actually just going to say here, I'm going to paste relative references there. I'll say whenever the frame is greater than or equal to, you become active. So obviously you're not active at first, and then at a certain point you become active. So now the RBD bullet solver will update the position, and there you go. So that's pretty good. Smash. Your sim may vary, based on how your fractures ended up happening or whatever. But this is good enough for our purposes. So that's our result. Pretty cool. We have 10 packed fragments and 1 packed USD. So again, SOP create will look at the packed USD and say, oh, I already know about this USD prim. Just update the position of it. As with the packed fragments, however, that'll be a new. Those will be new pieces of geometry that get added to our tree. So there we go. And let's come back out into here. Now I already know this technically isn't going to work, but I want to show you why. So there's the geometry, but where's the materials? The materials aren't there because it doesn't live in that same transform that has the material in it. It lives somewhere else. In fact, it lives here under SOP create 1. So what happened? Come back in here. Remember when we did this swap, attribute swap before? Well, first of all, let's put it here to match it so that our cork is doing the same thing. But we basically need to bring it back. We need to have our name attribute here. It became a point name attribute when we did the RBD configure. So we went from having the actual path as a path string primitive attribute. Then we swapped it with name because when we do the configure, it takes those attributes, see they're no longer, it takes it and turns it into a name attribute here. It makes a new path attribute that's useless to us. But our name, our point name now, because again, it gets put down into the point area because that's what the RBD bullet solver wants. It does all its stuff. It's still the same on the other side of this. As you can see, it's still there. And our path primitive is still useless. So now we need a promotion. We need to get it back up to the path, or rather to the primitive attribute level. So do an attribute promote. Where are you, attribute promote? There you are. So go from point to primitive, and it's the name that we want. So now it's back up here in the primitive area. And now we just need to swap them back. It doesn't even really matter what the name is called anymore. We just need one way or another to have the path be what it should, which is, again, a USD tree thing. So these new pieces of geometry we made now have actually nice USD paths. So save, come back out here, and now we can see they have their materials on them. If we open this up, you can see rigids, contents, instance 131. So there was our original cork and small jar with handle, and now you can see all of our new fracture pieces also living there. And they have that extra weird color because they're technically considered instances themselves, because they're packed geometry. So good. So that's pretty much it. We just need now to animate the visibility so we don't see both of these at the same time. So do that. Let's do a prune. The prune, we'll have this one be the prune that turns off the unfractured piece. So I can click this and try to get it. Say it's just not really working for me right now. You, not you though, just you. So I'm just gonna open it up and say, just small jar with handle, just drag it to there. And there you go, now it's off. Of course, now it's off all the time. So now even up here, we can see the fractured thing. It actually will look better than that within the actual Karma renderer. If we wait a moment for that to turn on. But nonetheless, we want to look as good as possible. So we want the unfractured one to be what renders. So once this starts up for the first time, it's very fast after that. Uh-oh, lost it. Let's go back into our camera. There we go. Uh-oh, lost it again. Anyway, so there you go. Gonna go back to Houdini GL, satisfied that works. So we want it to be on at first, then we want to turn it off later. So we know exactly when that is. Here's a fracture frame. So copy that, say, prune, when prune is set to 1, it will do this. And when it's set to 0, it will not do it. You can kind of see it turning on and off. I need to just select it again. There we go. So you can see, right now they're both on top of each other. So we want this to do the prune when the frame number is greater than that fracture frame. So just say like so. And the other thing is the other prune. The other prune only wants to work on the fractured pieces. The fractured pieces are, let's just grab any of these. And you can see it's basically just the same, but with this underscore. So do underscore star. And we'll say, when should this be active? Well, anytime that this one's not. So copy the original one here. Go to the new one and paste relative references and put an exclamation point to do the opposite. So now that should work. So if I look at the wireframe, I don't see any of the fracture thing. So if I go back to this one, I can see the old fracture one there. So the result of both of these prunes should be no fractures. And when they hit the ground, fractures and no original. And it works. Awesome. And then we have a nice tree also. In USD, we can't have new geometry being made all of a sudden. We need to use visibility to do that. So you'll notice, when we did this original sim, obviously it exists the whole time, but even with the fractured geometry, it actually exists the whole time also. It doesn't necessarily need to exist in the right spot, but it needs to exist the whole time. Like so. Awesome. And we're just animating the visibility of it. And that's about it. The last bit of housekeeping we need to do is the idea of how we're going to export this. So the easy answer to that is a USD ROP. But as it is, I don't want to export out the entire full scene here. I don't want to export out the camera that I made. I don't even want to export out the various visibility changes that I made to the original scene. All I want is to export out how I moved the original jar and how I created the new geometry. And of course, how we animate that. So there's this weird node called a layer break. I shouldn't say it's weird, but anyway, there it is. I'm putting it after I make my camera here. What the layer break does, it's weird because there's no parameters. But what the layer break does, essentially, it says everything is still the tree. Like we still have the full tree with all of the market scene and everything else. But when it comes time to export, only export the stuff after the layer break. That way, our USD scene is just basically a bunch of overrides in a sense. Now the issue is, well, this will be good to make sure that we don't export the original market scene or the new camera that we made, but we also don't want to export this visibility change here either. So this gets a little weird, where I'm basically going to say another layer break after this prune. So what you're probably thinking is, well, won't this layer break exclude this extraction? And if we don't extract our instance and make it into full geometry, how are these overrides? Like these overrides say to move that geometry around, but if it doesn't exist, it won't work. And you actually are right. So what we need to do is combine this where the extraction is performed and we're collecting that. And then everything else happens also. So what's getting missed? This prune is getting missed because this stream consists of everything after this layer break, right? And this stream consists of everything after this layer break. Altogether, we now have a collection of of everything that we've done. And to ensure that we don't have any duplicate work where this stream, that really should just do it, but just to be sure, I would like to say flatten all layers. We don't want to have any duplicate business going on. Just make it down into a nice new layer that we'll use to pass on to the downstream. So say render specific frame range, we want the full frame range. We can save it obviously to wherever we want. Save it. And I'm just going to save this file out and then we'll read it back in basically just as a sublayer. And if you were working in a studio or whatever, it's just this USD file that I would pass on to let's say the lighting department or the layout or to whoever might be interested in the changes that I made. So to demonstrate that, if we come back all the way back here to the sublayer, obviously, if I scrub this jar is just sitting on the shelf here. But let's say I make another sublayer, connect it. I want to add that thing that we just made, that file rather. So I'm going to copy that parameter and I'm going to paste relative references it here. It gets confused for a minute, but it'll be all right. And you can see it added that in. I was trying to ignore it when just the materials here changed, but now that my fractured pieces aren't showing up, that's weird. The thing is, this is really just, unfortunate bug. If you were to, probably, there you go, disabling it and re-enabling it, and now they're going through the materials back too. There's some bugs here and there, but, it's these bugs are getting squashed all the time, and the overall technology is super great. It's hard to overstate how powerful it is to have, these definitions of scenes built as a series of layers that become these trees and the fact that as an effects artist, I can just pass on my little collection of modifications and additions and have it just get bloop, plopped right down via this node into the grand scheme of it. And there you go. And people can just turn my work on and off. Animators can see my work. The lighters, again, it's not those crazy like juggling of alembics and translating things back and forth. You know, once your whole pipeline is using USD, it's super cool. So there you go. So that's it for my demo. And hope you like breaking pots on the ground, because I sure do. Bye.